Hello friends, in this tutorial we are going to learn about algorithms, its time complexity and space complexities. So what is an algorithm? It's a step-by-step procedure. Algorithm is step-by-step procedure which will have finite number of steps and it is ambiguous in nature. And it is written more effectively. Effectiveness, efficiency, finiteness, unambiguous nature, these all are the properties. Finiteness, its definiteness, and input, output, effectiveness, unambiguity, all this describe its properties, the characteristics of algorithm. Now, the performance of algorithm. How the performance of algorithm is determined? Performance of algorithm depends on two complexities. One is time complexity and there is space complexity. What is time complexity? The amount of time taken to execute the program. How much time it takes to execute a program. If it is 1 second or it is big O of 1, big O of n, it is calculated in the big O or big omega. In this situation we get to know what is best case, worst case or average cases. So at what time, in how much time it is executing the program is determined by the time complexity. And space complexity, how much memory it is taking, is determined by the space complexity. Now how we analyze the complexities. So let's take f of n equal to 2n power 4 plus 2n cube plus 3n square plus n. So we have few rules to get this time complexity. How is? Let's consider the highest degree. We will consider only the highest degree, that is 2n power 4. Degree is 4 here. It is the highest one. So we consider this 2n power 4. Now we discard this coefficient. So we will have n power 4. So time complexity of this is big O of n power 4. In this way we analyze the expressions. Now if we have programming code, let's take a programming code. Int a equal to 1 for I equal to 1, I less than or equal to n, I plus plus, printf %d so and so, and next. So how we do this? Int a equal to 1. So for one integer variable, it will take big O of 1 time for executing this one line. For executing this I equal to 1 to n, it will take big O of n time. For n elements, it will take n time. So the total time complexity is taken as big O of 1 plus big O of n. But finally we will take big O of n as this is the larger one. So how much time it will take to compile the complete program will be based on this, the highest one, that is big O of n. This is how we do. This is the first rule. This is for first rule if we have expressions. And this second rule, we consider this and we will do easily. Now we have one more rule, that is rule 3 for this. That is, we will take step count, we will take frequency, and we will take line number. What is the step count? Step count for flower braces is 0. And for any other cases, See, for this flower basis it is 0, but for any other line step count will be 1. And frequency, number of times the particular line is executed. Now we have this line is executed one time, we will put 1, but this line it is executing n times, so for this we will put n. So that is the frequency. And line numbers starts from 1, 2, 3, 4, 5, 6 in this way. And one more thing, we consider number of times along with this 3, fourth one. Number of times is product of step count and frequency. So now let's see a problem with it. For function int I, for I equal to 0, I less than n, I plus plus, printf some percentile d something close. So for this how we do? Step count, line number, frequency, and number of times. Step count, line number, frequency, number of times. So line number is 1. For the step count is 0. As for flower braces it will be 0. For remaining it will be 1. And frequency of this is 1 because it is executed only once. Number of times will be step count into frequency. So 0 into 1 is 0. Next, line number 2. Step count is 1. And how many times it is executed? It is executed only once. So frequency is 1. Step count in frequency is 1. Now this, line number 3. This one is executed. Its step count is 1. And frequency, how many number of times it is executed is executed n plus 1 times. So 1 into n plus 1 is n plus 1. And now line number 4, step count is 0, frequency is 1, 0 into 1 is 0. Here line number 5, step count is 1, line number is 5, so step count will be for this is 1. And here percentile d, and here some solution for this will be I. So I we have 0 to n, so frequency will be n. It will update n times, so it will visit number of times is n times. So 1 into n is n. And this is 6, this is 7, step count is 0, 1, 1, 0, 0. So total is n plus 1 plus n plus 1, n plus 1 plus n plus 1. So it is 2n plus 2. This is the total time complexity of this. Total time complexity is 2n plus 2 for this problem. So in this way we can find the time complexity for the algorithms by applying few rules. First rule is on the expressions, discarding considering only highest degree, discarding the coefficient, taking this. This is the time complexity for this. Second thing, we can consider normally. Big O of 1, big O of n, we can take it like this. Third thing, we will take step count, line number, frequency, number of times, and we calculate this. This is the most efficient way we can get the time complexity. So if you like this video, please do like, share, comment and subscribe, and please click on the bell icon so that you will get to know about the new notifications of the new videos. Thank you.